Hi students, just now we have defined what is meant by work done and the two conditions to be satisfied for work to be done. Now once again, you look at this example where there is a toy with the wheels and there is a string. So along the string I am going to apply a force F, and now when you apply a force along the string, the toy is not going to move along the direction of the force here, because the toy is kept on the floor, on the horizontal surface, but the string is inclined to the horizontal surface. So the string makes an angle theta. In this picture it is an acute angle less than 90 degree. So the force is acting at an angle theta with respect to the horizontal, with respect to the x direction. So the toy is not going to move along the string, but it is going to move along the horizontal direction. So this will be the direction of the displacement. Can you understand that theta is the angle between the force and displacement in this example? Yes, force and displacement are not acting in the same direction. Now the force which is actually applied on the toy, on the object, is F Newton. But along the direction of displacement, how much quantity of force, how much portion of this force is going to act along the direction of the displacement is a question. So the entire force is not going to act along the direction of displacement. A portion or a fraction or a part of this force F is going to act along the direction of this displacement. That is nothing but it is F into cos of theta. So along this direction, what portion of this force is going to act is F into cos of this angle theta. So what is meant by cos of theta? For that I am going to take this right angled triangle ABC. So B is right angled here and angle A is an acute angle that is equal to theta. Now any side which is opposite to this 90 degree, opposite to this right angle, say in this example it is AC, this side is opposite to 90 degree, so it is called hypotenuse, and the side AB which is nearest to this theta is called the adjacent side, and the side BC which is exactly opposite to theta is called the opposite side. So this is adjacent side AB and BC is the opposite side to the given angle, and AC is called the hypotenuse. Now here cosine, that is cosine value of theta. In mathematics you must have studied what is meant by sine value of theta, cos value of theta and tangent or tan value of theta. We need only the cosine value of theta, that means cos of theta. So cos of theta is equal to adjacent side divided by the hypotenuse. So this is the mathematical step. We are not going to derive all the equations like sin theta, cos theta and all. But there are some values assigned for theta. If theta is 0 or 30 degree or 45 degree, 60, 90, 180, what is the value of cosine value? What is the cosine value of theta? You must remember. So I am going to write here cos of 0 degree. Okay, this is equal to 1. And cos of 30 degree is equal to root 3 by 2. And cos value of 45 degree is equal to 1 by root 2. And cos of 60 degree is equal to 1 by 2. And cos of 90 degree is equal to 0. Cos of 180 degree is equal to minus 1. These values you must be remembering. Okay students? So the reverse of this will be what? The sin theta. For sin theta, if you take sin 0 will be equal to 0, sin 30 will be equal to 1 by 2, sin 45 is equal to 1 by root 2, and sin 60 is equal to root 3 by 2, sin 90 is equal to 1. The reverse of cos value will be the sin value. So these values you will have to remember at this 9th standard level. At least the values you have to remember. So depending upon what is the value of this theta, or depending upon what is the value of cos theta, sometimes the work done by this force may be positive, or sometimes the work done by the force may be negative, or the work done may be zero. So now we are going to introduce that there are three types of work. The work done may be positive or negative or zero. Okay, students. So from this picture, what is the actual force acting on the body is F Newton. And what is the displacement produced along the x-axis is S. But a certain portion of the force, a certain component of the force is acting along the direction of the displacement, that is equal to F into cos of this theta. Understand? So now here work done W is equal to F cos theta into S. F cos theta into S. So depending upon the value of cos theta, the work done may be positive or negative or even zero. Okay, students. So for example, now I will take a positive work done. So case 1, I will take a case 1. So work done is positive. So for this I will consider an object. Okay, this is an object, and it is being pulled by a string. It is being pulled by a string by applying a force F Newton, so that the object is also moving along the same direction of the force. So it is very clear in this picture, both the displacement S and the force applied F are in the same direction. So what must be the angle between this F and S here? In this case theta is equal to 0 degree. Is it not? Therefore work done is equal to F into cos of 0 degree. Okay, cos 0 into S. So what is cos of 0 degree is equal to cos 0 is equal to 1, is it not? Therefore so this is equal to F into S. So the work done is said to be positive when the force and displacement are acting along the same direction. Understand? So not only for 0, even in this case for acute angle, whenever the force makes an acute angle with the direction of the displacement, then the work done will be positive. Okay, in this case theta is equal to what? 0. Therefore the force is directly work done by the force is directly equal to the product of the force and the displacement. Now for example, you lift an object from the ground surface. So let us take, this is the ground surface. On the ground surface a box is kept, and you are going to lift this box in the upward direction. So applied force is in the upward direction. Displacement is also produced in the upward direction. So while lifting a bucket of water, while lifting a suitcase, like that, the applied force and the displacement are in the same direction. So in this case the work done by the force is positive. Okay, now second case, we will now explain the second case. The work done is negative. When will be the work done negative? Let us see now. For that I will consider case 2. So this is a negative work. In our everyday life, so many examples we come across where work done is negative. So for example, I will consider this is an object which is tied to a spring. Okay, this is tied to a spring. Let us take, this is tied to a spring. Suppose I will apply a force in this direction. So this is called as the applied force. This is the applied force. So when I apply a force, the spring gets stretched. Okay, the spring will be stretched like this. So that this is the wooden block which is tied to the spring. So can you all see here, students, when I apply a force, I just pull the wooden block which is connected to the spring. So this is a direction in which I am applying a force, and there will be a force which is going to pull the block in the opposite direction. So when I leave this block, at that moment, what is going to happen? It will go back to its original place. It is going back to the original place, is it not? So this force is called as a restoring force. So restoring force. Applied force is acting along the x direction, and restoring force is acting in the opposite direction. So when I apply a force, displacement is produced along the same direction. Understand? So displacement is produced along the x-axis. In the first case, you see that the applied force and the displacement are in the same direction. While pulling a spring, in which direction you pull, in the same direction only the wooden block is also moving. Therefore, in this case, what is the angle between the applied force and the displacement? It is 0 degree. Understand? Whereas in this case, you see what is the direction of the displacement is along the x-axis. What is the direction of the restoring force, spring force? That is in the opposite direction. So what is the angle between the displacement and the restoring force is what? 180 degree. Is it not? So in this case, so theta is equal to 180 degree. In this case, theta is equal to 0 degree, where the work done is positive. In the same example, we can explain what the negative work done. So as per the definition of work done, this is equal to F into cos of 180 degree into displacement. So what is cos of 180 degree? It is minus 1. Therefore, this is equal to minus F into S. Therefore, W is equal to minus F into S, that is equal to negative. Have you understood, students? Have you understood? So many examples can be given. See, for example, I will consider an object is placed on the ground surface. Okay, on the ground surface. Now, I pull this in the upward direction. So, in the upward direction, this is applied force. Applied force is acting in the upward direction. Displacement is also produced in the upward direction. But in the same example, you will see that the weight of the body is acting in the downward direction. That is called as F gravitation. The gravitational force acting on the body is always in the downward direction. So in this example, the applied force and the displacement are in the same direction. So what must be the work done by the applied force? Yes, that is positive. So in the same example, now you tell me the direction of the gravitational force is downward and the direction of the displacement is upward. So what must be the sign of the work done here by the gravitational force? It is negative. So the work done by the gravitational force is negative because the angle between F gravitation and the displacement is 180 degree. Like that, when we climb up a staircase, you keep a ladder or staircase you consider. When you climb up by keeping a heavy luggage on your head, means while going up, okay, the gravitational force or the weight of the luggage is acting in the downward direction. So since you are moving in the upward direction, the gravitational force is acting in the downward direction. Therefore, the work done by the gravitational force is negative. Now, another best example is, suppose you take this is the ground surface and an object is moved. Okay, so it is moved in the forward direction by the applied force. Since there is a contact of this body with the floor or the ground, there will be a frictional force. And the frictional force will be acting in the opposite direction. Okay, so in this case, applied force is in the forward direction. So body is moving along this direction. Along the applied force, the body is moving. It produces a displacement, yes. But in which direction is the friction is acting? Frictional force will be always acting opposite to that of the applied force. Therefore, what is the work done by the frictional force? Frictional force is opposite to the direction of the displacement. So what is the angle between frictional force and displacement? It is 180 degree. again what is the work done? Work done must be equal to what? Minus of F is F into S, that is negative. So like this, many examples can be given. I hope you must have understood negative work done also. Now along with this, zero work done is the next case. So case 3 is zero work done. Now when will be the work done zero? Under many conditions. Under many conditions. You see here, this is also interesting. Case 3. So zero work. So W is equal to 0 means F into S must be equal to 0. So either F is equal to 0 or displacement is equal to 0 or angle theta between them is equal to 90 degree, so that cos 90 is equal to 0. So how many conditions are satisfied? If F is equal to 0 also, what work done is 0. If displacement is 0 also, work done is 0. Or if the angle between force and displacement is 90 degree, then cos 90 is also equal to 0. Therefore work done is equal to 0. Under all these conditions, work done will be equal to 0. Now in uniform circular motion, we have studied uniform circular motion. In uniform circular motion, a particle or a body is moving along the circumference of a circle. Okay, circumference of a circle. Now let us consider that this is our earth. So surrounding this earth, artificial satellites. Okay, some artificial satellites are revolving. Okay, some artificial satellite is revolving around the earth in the circular orbit like this. So this is the radius. This is the radius. So in uniform circular motion, what is the direction of displacement or velocity of this body in revolution? A tangent you have to draw to the circular path, and this will be the direction of the displacement as well as the velocity. So this tangent to the circular path will give you the direction of the displacement, and there will be a centripetal force acting along the radius towards the center. So there will be centripetal force acting on the satellite. If this force will be always acting towards the center, that is here towards the earth. So at every point, whenever the satellite is changing its position, at that position if you draw a tangent, say for example at this position also, if you draw a tangent, means this will be the direction of the displacement, this will be the direction of the force, which are always perpendicular to each other. So what is the work done? What is the work done here? In this case, work done is equal to F into cos of 90 into S. So this is equal to 0. So the work done by the centripetal force in uniform circular motion is equal to 0. Okay, students? So now we have discussed the three types of work done. So when is the work done said to be positive? When the angle between the force and the displacement is an acute angle. Perfectly, if it is 0 means 100% it is positive, definitely. So if it is an acute angle also, then the work done will be positive. When it is an obtuse angle means then it will be negative. So in short, we can say that if force and displacement are in the same direction, work done is said to be positive. If force and displacement are in opposite directions, then the work done is negative. If force and displacement are at right angle to each other, then the work done is said to be 0. Okay, so with examples, the three types of work done we have understood. So what is work done? What are the conditions required for work to be done? What are the different types of work done, namely positive, negative and 0 work done we have studied. And one more information we have to remember is this work done is a scalar quantity. The work done is a scalar quantity. That means it has only magnitude. So it has only magnitude but no direction. And what is the SI unit of work done we have studied is either joule or Newton meter. Also we must remember that 1 joule is also equal to 1 Newton meter. Okay, fine students.